All right, here we got the Math 3 6.5 notes, rational exponents. So rational exponents basically means our exponent is going to be a fraction. So you can kind of think of this as fractional exponents. Fractional, okay? All right, so anyways, our exponents are just going to be fractions, okay? And then, we'll get through the details and the definitions and that sort of thing, but the whole idea behind these set of notes is being able to go backwards and forwards from a fractional exponent to another statement written in expanded form. In other words, if I have something like this, a raised to the, let's say, m over n, and I don't usually like using those letters because they kind of look similar. We'll zoom in a little bit, okay? But that's the same as this. Taking the nth root of a, whatever n happens to be, and then raising that to the mth power. Okay, so again, that's my n here, my m there. Okay. There's different ways to write this, but this is the way we want to prefer it. Okay, and then how do we remember the order here? Okay, so if I get something like this, how do I write it with a rational exponent? Okay, so what goes on top? Well, the power that I'm raising it to, because we raise it up to the top, that's going to be on top. And then the root, so think like a tree, roots are on the bottom. Okay, those go on the bottom. So it's the power on top, the root on the bottom. Okay, so we'll see more examples of that throughout the set of notes. All right, so the first thing they want us to do, they're asking us, how do we write root 11 with a rational exponent? Now, if there's no exponent, because sometimes the exponent can be on the inside of the radical, like it shows us in the rule down here. Okay, if there's no exponent, we can think of that as 11 to the first power, or I can think of it as I'm taking this whole thing and raising it to the first power. Okay, and then how do we write that with a rational exponent? Well, the first thing we always want to do is figure out what's our base. What's the thing that we're raising to a power? 11. Okay, so I got to start with 11. Okay, and then anytime we're dealing with a radical, whether it's the square root, cube root, or whatever, fifth root, fourth root, doesn't matter, our exponent is always going to be a fraction. So I'm going to write my little fraction bar up here. And then next, well, what power are we raising this thing to? Well, the first power, so then that goes on top. And then what root are we taking of 11? Well, the square root, which is the second root. So the square root of 11 is the same as 11 to the 1/2 power. This is a very common exponent. You're going to see this come up a lot. Okay, and then that's all they really want there is that. So again, where did that come from? Well, we had the square root, which is the second root of 11, raised to the first power, and then that's the same as that. It equals that. Okay. All right, moving on to the examples here. Example 1, simplify the following expression with a rational exponent. Okay, so we've got the cube root of 27. Now, before we just go ahead and simplify, how else can we write the cube root of 27? That's the same as what? I'm going to go backwards here. That's the same as 27 raised to what power? Well, we're raising it to the first power, and then I'm taking the third root. So sorry, there's not a lot of room right there. But that would be the same as 27 to the 1/3 power. And then how do we simplify that? Well, hopefully we have this one memorized now. That's one of our perfect cubes. But I can always do it by factoring. 27 is 3 times 9, and 9 is 3 times 3. I need 3 of something to pull one out. So let's see, yeah, I have 3 3s. So I can take out a 3, and there's nothing left over, so we're done. Okay. Next, how do we simplify this one? Well, again, we want to do it by factoring. I'm looking for groups of 5 here in order to pull something out. But first, what's that the same as? How can I write this thing with a rational exponent? Okay. Now, later on, especially in a different unit, our logs unit, we're going to look at writing this thing with a different base. Instead of 32, I could write this maybe as 2 to a power. But we'll deal with that later. Right now, my base, the thing I'm raising to a power, is 32. There's a radical, so I know it's going to be a rational exponent, a fractional exponent. Let's see, I'm raising this to the first power, because there's no other exponent there, and I'm taking the fifth root. So then 32 to the 1/5 is the same as the fifth root of 32. And then how do we simplify that? Let's see, 32 is 2 times 16, 16 is 2 times 8, 8 is 2 times 4, 4 is 2 times 2. Okay, so we need 5 of something, since it's a fifth root, to pull one out. And I have 1, 2, 3, 4, 5 2's. Perfect. So I can group these together. That allows me to take out 1, 2. And then is there anything left over? No. So then my answer is just 2, because they're asking here, what times itself 5 times equals 32? Well, 2 times 2 times 2 times 2 times 2 equals 32. So our answer is just 2. Okay, and then the last one over here, the 4th root of 81. Well, first of all, how can we rewrite that as 81 to what power? Well, we're just raising it to the 1st power and taking the 4th root. So that's 81 to the 1/4 power. Okay, and then what is the 4th root of 81? Well, 81 is 3 times 27. 27 is 3 times 9. 9 is 3 times 3. Again, it's a 4th root. Do we have 4 of anything? Well, sure, we got 4 3s. So then we can take out a 3. And then there's nothing left over, so our answer is just 3. Okay? All right, a little intro into rational expressions there. Next, rational exponents. There's different ways we can display our answer. Okay, so if I have something, let's look at the middle one. In this form, I've got the nth root of something raised to a power. Well, I can either write it like this with the exponent on the outside or the inside, or I can write it with a rational exponent. Or here we have a rational exponent. Again, there's just different ways to write it. This is kind of going back to what we talked about up here. There are different ways to write your answers. This is probably the way I'd recommend. This is going to work out the nicest in most of your problems. Okay. Sometimes we want it in this form, we can simplify. Sometimes we want it in that form, because sometimes, as we'll see on the back page, our exponent rules are easier to use. Okay, so anyways, we'll get to that stuff later. So don't get too hung up on this stuff here. It's just showing different ways you can display your expression. Okay. All right. Example number 1. I guess it's a second example number 1. Little typo there. Here it says write each radical expression in exponential form. So we're not solving for anything. We're not solving for t. We're not getting an answer. We're just going to write it in exponential form. Okay. Sometimes they want it in exponential form. Sometimes they want it written like this in radical form. Okay. All right, so again, the first thing you want to figure out is, what are you raising to a power? What's our base going to be? Well, t. So I know we're going to have t to a power. Anytime we have a radical, we know our power, our exponent, is going to be a fraction. So we'll go ahead and put the fraction bar. And remember, we raise it to the power goes on top, and then just like a tree, roots are on the bottom. The root we're taking is on the bottom. So what power am I raising t to? Well, to the 2nd power. So the 2 goes on top. And then we're taking the 3rd root of t, so then the 3 goes on bottom. So t to the 2/3 is the same as the cube root of t squared. And then that's it, we're done. They just wanted it in this form. Okay? All right, next one. We've got 6 times the cube root of h to the 4th. Okay, well then this is going to be 6 times something. Don't worry about the 6. We want to focus on just this part here. How do we rewrite the cube root of h to the 4th? The 6 has nothing to do with this. Okay, it's just on the outside there. We're multiplying by it. Okay, so leave that alone. And then how do we simplify the cube root of h to the 4th? Well, what's my base? What's the thing we're raising to a power? Well, that would be h. And then I know since there's a radical, my exponent is going to be a fraction. What power am I raising h to? All right, there, the 4th power. Okay, again, that exponent could be on the inside of the radical or the outside, doesn't matter. We're raising it to the 4th power, and we're taking the 3rd root of h to the 4th, so then the 3 goes on the bottom. Okay, so then my answer is, well, we don't really have to even rewrite it, but we have 6 times h to the 4/3 power. That's just 6h to the 4/3. So we can rewrite it without the parentheses, and then that's our answer. Okay, but again, if you have something on the outside, just leave it on the outside. It's just a multiple of that thing. All right. Next one, let's zoom in a little bit. We don't need to be zoomed out that far. We have the 4th root of 16a to the 8th. Okay, now there are different ways to do this. If all they want you to do is write it as an exponent, great, you can do that. And then you can reduce the exponent if possible. Or sometimes you can simplify it first. For example, could I simplify this thing, the 4th root of 16a to the 8th? Sure, let's do it 2 different ways. So first, if I didn't want to mess with simplifying anything, and I just wanted to write it with a fraction, with an exponent that is a fraction, okay? How would we do that? let's see, I'm taking the fourth root of something. So let's see, I'm taking the fourth root of 16, a to the 8th, sorry, a to the 8th. And then I'm taking the fourth root of that. Well, the fourth root is the same as the 1/4 power, okay? And then if I have a product and I'm raising it to a power, well, then we want to distribute the exponent to both these terms here. We learned this last year in Math 2. So then we get 16 to the 1/4, and a to the, well, 8 times 1/4 is 8 times 1/4 is 8 over 4, which reduces to just 2. Okay, so we get 16 to the 1/4 times a squared, which equals what? Well, what is 16 to the 1/4 power? In other words, what's the fourth root of 16? In other words, what number times itself 4 times equals 16? Well, 2. So we get 2a squared. Okay, so then this would be our answer. Okay, now that's one way to get it. That's by putting it in exponential form and then using our exponent rules. How else could we have done this problem? So we have the fourth root of 16a to the 8th. Okay, well, the other thing we could have done is just simplify this radical right away. If I factor 16, I'm going to get 4 2's. We don't have really room to show that work, but we get 4 2's. So then I can take out a 2 and nothing's left over. And then what's the fourth root of a to the 8th? In other words, if I have 8 a's, how many groups of 4 can I make? Well, 2, so I get a squared. So this one worked out pretty nice, just simplifying the radical. Or we could have done it using different steps using our exponent rules. But either way, we get the same answer of 2a squared. Okay, so sometimes we want it in exponential form, sometimes we want it in radical form. Okay, it just depends on which one's easier. All right, next example. They want us to simplify 64x to the 1/6 power. Okay, so here, again, we can use exponent rules, especially if you rewrite 64 as a smaller number raised to a power. Or what might be easier, a little bit simpler for us at this point in the class, let's just write this in radical form. This is the same as taking the 6th root, because roots are on the bottom, of my number 64, and then raising it to the first power, which we don't really need to bother writing the first power thing. We can just ignore that. Okay, and then what's the 6th root of 64? I'm going to write kind of small so I don't, get too low down here. But let's see, 64 is 2 times 32. 32 is 2 times 16. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. So we've got 1, 2, 3, 4, 5, 6 2's, which is perfect because we need 6 of something to pull one out. So then I can take out a 2, and nothing's left over. So my answer is just 2. Okay. Now, let me show you real quick, just because we have a little bit of space here. The other way we could have done this problem, I have something raised to the 1/6 power. Okay, well, what do I have raised to the 1/6 power? 64. Well, how can we write 64? Well, any way that we want to. I can write it as 2 times 32, or I can write it as 4 to the 3rd power, or I can write it as 2 to the 6th power. Okay, and then what's 2 to the 6th to the 1/6 power? Well, like we learned last year, for raising a power to a power, I multiply these things, and I get 2 to the 1st, which is just 2. Okay, so you can see sometimes it's a little bit easier to use the exponent rules. Sometimes it's a little bit easier to use the just simplifying rules of radicals. Okay, so anyways, 2 different ways to solve the same problem. We won't do the other ones 2 ways anymore. We'll just pick the easiest way. Okay? All right, let's do the one right below it here. 125 to the 4/3 power. Let me adjust this camera a tiny bit. All right, so how are we going to do a problem like this? It's probably going to be simpler for most of you guys because you're most familiar with it, to put it in radical form first. So here we want the 3rd root of that number. So I want to take the 3rd root of 125, and then I'm going to take that answer and raise it to the 4th power. Again, I like writing it like this with the exponent on the outside. If we put the exponent on the inside, well, then I need to raise 125 to the 4th power first, which is going to give us a huge number, and then I need to take the cube root of that huge number. That's going to be hard. If we take the root first, it's going to keep our number smaller and make this thing easier. Okay, so let's see. This is going to equal something to the 4th power, and then what is the cube root of 125? Well, 5. And then what's 5 to the 4th power? 5 times 5 times 5 times 5. We get 625. Okay? And then that's how we can simplify that one. All right, two more on this front page. All right, 16 to the 1.25 power. Okay, now we don't want to have decimals in our exponents. That's no good. I know we don't like fractions very much, but they're actually easier to work with than decimals. So instead of 1.25, how else can we rewrite that? Well, let's see, 5 is in the 100th place, so this is 125 100ths, okay, which would reduce to what? Oh, 5 over 4. Okay, so instead of 1.25, we're going to write that as 5 over 4. Again, this is 125 100ths, and then we just reduce that to get 5 over 4. Okay, now that we have it written like that with the rational exponent, we know how to work with that. Let's write it in radical form now. We want the fourth root, okay, because again, the roots are on the bottom of that number, and then I'll take that answer and raise it to the fifth power. Okay, so I'm going to raise something to the fifth power, and what is the fourth root of 16? What times itself 4 times equals 16? Well, 2. So then I want 2 to the fifth, which we saw earlier. It's just 32. 2 times 2 times 2 times 2 times 2 is 32. Okay? So that's how we do that one. Again, we don't want to work with decimals. We'd rather work with fractions. All right, last one. And again, it's not the only way to do these problems, but we're just doing what we think will be easiest for you guys. 81 to the 3/4 power. One way to solve this, to simplify this, I should say, is to write it in radical form. So then instead of 81 to the 3/4 power, I want the fourth root of that number. To the fourth root of 81. I'm going to take that answer and raise it to the third power, because the power is on top. All right, well, what's the fourth root of 81? Well, we saw that earlier too. That was 3. So then I want 3 raised to the third power, which is, as we also saw earlier, 27. Okay, and then that's our answer. Okay, so again, not the only way to simplify these, but probably the way that you're most familiar with and will be most comfortable with for now. Okay, if you have any other questions on that, just ask me when I see you in class. All right, second page of the notes. Zoom out so you can see the whole thing. This whole top section is just the exponent properties of exponents that you learned last year. And nothing you really need to do with these. This is just kind of a refresher. What do we do if we have a power raised to a power? What do we do if we're dividing things with exponents? What do we do if we're multiplying things with exponents? This is just a reminder of all those rules. Okay? And then we got a few more examples down here where we're going to start using some of those rules. All right, so like it says, write the equation in simplest form. Also, keep in mind, this is one of those chapters where there's probably going to be different ways to get your answer on these problems. I'm going to try to show you a way that I think is easiest, but if you like a different way better, that's fine, as long as you end up with the same answer. Okay, so we've got negative 8y to the 9th, all that raised to the 1/3 power, and we want to simplify that. Okay, so for me, let's see, I'd probably just write it in radical form. Instead of the 1/3 power, the 1/3 power is the same as the cube root. So instead of raising this stuff to the 1/3 power, we want the cube root of this stuff. So let's write it like that. We want the cube root of negative 8y to the 9th. Okay? And then we just want to simplify that. Can I take the cube root of a negative? Yeah, sure. I just know that my answer is also going to be negative, so we got a negative there. And then what's the cube root of 8? What times itself 3 times equals 8? Well, 2 does. And then if I have 9 y's, how many groups of 3 can I make? Well, 3. So I can take out 3 y's with nothing left over. So my answer is just negative 2y to the 3rd. So again, not the only way to get that answer, but that's what we're looking for. Okay. All right, next. We've got the square root of this stuff, and we want to raise it all to the 4th power. Okay, so again, different ways to do this. For me, since we have the square root of this stuff, let's just take the square root of that stuff. Okay, and then we'll raise all that stuff, our answer for that, to the 4th power. All right, the square root of 9 is 3. Great. The square root of y squared is y, so we'll take that out. And then the square root of x, so we just got to leave that part as root x. Okay? And then next, I just want to raise all this stuff to the 4th power. So if I distribute this exponent to the 3 and the y and the root x, what do we get? So 3 times 3 times 3 times 3, because that's what it means to raise something to the fourth power. Multiply it times itself 4 times. That'd be 81. Y to the fourth is just y to the fourth. And then the square root of x times the square root of x times the square root of x times the square root of x is going to give us x squared. Okay? Because again, root x times root x is x. We have that twice. Or think of it this way. I can rewrite this as x to the 1/2 power. 1/2 times 4, I get 2. Okay, so that's one way to do it. Let me show you another way to do this one, just as an alternative. Okay, so let's see. First of all, we've got a bunch of stuff raised to the fourth power. And what are we raising to the fourth power? Well, the square root of all this stuff. Okay, well, instead of writing it as the square root of this stuff, I can write it as this stuff, 9xy squared, raised to the 1/2 power. Okay, so this is an alternative way to do it. Instead of the square root of this stuff, I can write it as this stuff to the 1/2 power. I'm sorry about that. Didn't show the fourth part there. Okay, next, if I have this stuff to the 1/2 power to the fourth power, well, when we have a power raised to a power, we multiply those, right? So then I can multiply these two things and get 2. So then instead of this stuff to the 1/2 to the fourth, it's just this stuff to the second power. Okay, and then next I want to just distribute that exponent. Well, 9 squared is 81. X squared is just x squared. And y squared squared, multiply those to get y to the fourth. And again, technically the order doesn't matter. Normally you put it in alphabetical order. But yeah, these two answers are the same. Okay, so there's different ways to do these problems. Do them whichever way you think is easiest. All right, last two here. And again, do these whichever way you think is easiest. All right, so we got a fraction raised to the negative 1/5 power. Okay, now the first thing I'm going to do is look to see, can I simplify that fraction? So I got x to the fourth over x to the negative 1. Okay, so for me, I would first simplify the fraction. Since this has a negative exponent, I want to bring it to the top, and that's going to give me x to the first times x to the fourth raised to the negative 1/5. And then x times x to the fourth, we get x to the fifth to the negative 1/5. Okay. And then now since I have a power raised to a power, we get x to the fifth to the negative 1/5. We want to multiply those exponents, which gives me x to the negative 1, which, like my rule says up here, if we have something raised to a negative exponent, we want to flip it. Okay, so then x to the negative 1 is the same as 1 over x to the positive 1. So 1 over x is my answer. Okay, so again, not the only way to get that answer, but it works. For example, we could have distributed the negative 1/5 to both those things and then gone from there, but I think this probably was pretty clear and easy. Okay, and again, if you have questions on problems, just let me know in class. I'd be happy to go over them with you. All right, and then the last one here, x to the 1/3 over y to the negative 2/3, all raised to the 9th power. Okay, this time, let's do it a little bit different than we did the last one, because I can't combine these things anyways, because this is an x and this is a y, so my bases are different. So let's go ahead and distribute this exponent. I want to distribute the 9 to that exponent, and the 9 to that exponent. And when I do that, x to the 1/3 to the 9th, well, 9 times 1/3 is 3, so I get x to the 3rd, over y to the negative, and then 2/3 times 9. So again, 2 times 9 is 18, divided by 3 is 6. So we just get negative 6. Okay? All right, so that's nice. And then the last thing we got to do is just make this exponent positive by flipping it to the top. So we get x to the 3rd times y to the positive 6. And that's our answer. Okay? So you're going to be doing two things a lot in this section. You're going to be using these exponent rules that we've learned in the past, but we probably haven't used much lately. And then the other thing that we're going to be doing a lot of is this right here, converting from exponential form to radical form, and vice versa, from radical form to exponential form. Okay? All right, and then that wraps up the notes for 6.5.